On Chapter 10, Section 4, Solving Radical Equations, our learning objective is to solve equations containing radicals and to identify extraneous solutions. First thing we need to talk about is a radical equation. A radical equation is an equation that has a variable in the radicand. And if you look, that's like this example right here, I have an x underneath the radical. We get to be a radical equation. So our operating procedure is we're going to solve by squaring both sides and checking solutions. In the middle of that, there's the isolating x, but I'll show you how that works here. So if we look at our sample equation, we have square root of x minus 5 equals negative 2. So we're going to get everything not the radical, we are going to move to the other side. So we're going to add 5 to both sides so that I have square root of x is equal to negative 2 plus 5, which is 3. Then we are going to square both sides, because the only way to get rid of a square root is to square. And when we do that, we see that x is equal to 9. And then make sure we want to check our answers, because sometimes things get squirrely when we have square roots. So we're going to check to make sure that 9 works in this problem. And we get negative 2 equals negative 2. Chickadee check. All right, so let's take a look at this scenario where we have the square root of 7x minus 4 equals the square root of 5x plus 10. So now everything is covered in square roots, so I can't really shift or shimmy any of these around. You can't, when you have a plus or a minus underneath the square root, you can't take things out of it piece by piece. That only works when you have multiply or divide. So when I'm looking at these two, I can't just take the minus 4 out. I have to leave it in. I have to deal with it as it stands. And the way I'm going to get rid of square roots is I'm going to square both sides. So when I do, I get 7x minus 4 equals 5x plus 10. Yay! So I'm going to subtract 5x from both sides. And then add 4. And I get 2x equals 14. And then divide by 2. And I get x equals 7. Yay! Easy. Let's do a check, though. Because when I have square roots, we start getting a little crazy. So I'm going to replace x with 7. So this is 49 minus 4 square root, and this is 35 plus 10. 49 minus 4, square root of 45, and 35 plus 10 is square root of 45. These are definitely equal. So this answer checks out. All right, here it is, extraneous solution. So I'll highlight, I just snipped this from your book, so I'll highlight what I want you to write. An extraneous solution is an apparent solution that does not satisfy the original equation. Extraneous solution is a solution, an apparent solution, so you have to solve for it first. That does not satisfy the original equation. All right, so let's try to find the solution of negative y equals square root of y plus 6. So I'm looking at it, is everything, do I have a radical on one side and everything else on the other? Yes, I can't separate the y plus 6 because it's connected with a plus. And once you're married with a plus or minus, can't get rid of them. So I'm going to get rid of the square root by squaring, and my book would like me to remind you that when I take negative y and I square it, it's like having negative y times negative y, which is the same thing because a negative and a negative will give you a positive. So then I have positive y squared. So this guy is positive y squared equals y plus 6. So now I have I have a quadratic equation. Oh no, chapter 9 coming back at me, haunting my dreams. So I'm going to move the y plus 6 to the other side so I can get a nice quadratic. When I do that, I get y squared minus y minus 6 equals 0. And we know that we can factor which two numbers multiply to give us negative 6 and add to give us negative 3. Sorry, and add to give us negative 1. Seems familiar, right? And this is the factoring we did in chapter 8, so it's all coming together, all layering on top of each other. So I'm going to go with 3 and 2, because I know 3 minus 2 is 1. But I don't want 1, I want negative 1. So the 2 has to be positive and the 3 has to be negative. So when I'm looking at solutions, I have y plus 2 equals 0 and y minus 3 equals 0. So my two solutions are y equals negative 2 and y equals 3. But I have to choose. So let's go check it. I take my original equation and I put in negative 2 and then I see if it works. Negative and a negative give you a positive, and negative 2 plus 6 gives us 4. Let's try writing the correct book. 2. This gives us 4. Square root of 4 is 2. Is 2 equal to 2? Yes? So this is for sure a solution. So pour 3 over here. We have to see if 3 cuts it. So negative 3 equals square root of 3 plus 6. Negative 3 equals square root of 9. Negative 3 equals 3. True or false? Negative 3 equals 3. No. Wait. Negative 3 does not equal 3. Okay. So y equals 3 is the extraneous solution. All right, so this is our last one. What is the solution of 6 minus root 2x equals 10? So I'm going to write that here. 6 minus root 2x equals 10. So I want to isolate everything away from the square root. I'm going to minus 6 from both sides. And I'm going to divide everything by negative 1 so I can get rid of the negative here. And I get square root of 2x equals negative 4. So I'm going to get rid of the square root by squaring both sides. And I get 2x equals negative 4 times negative 4 is positive 16. Then I'm going to divide both sides by 2. And I get x equals 8. After I do all that, I'm going to plug 8 back in. So here's my check. So I got 6 minus square root of 2 times 8 equals 10. So 6 minus square root of 16 equals 10. And I get 6 minus 4 equals 10, or 2 equals 10. Working? Alright, so we have to evaluate. 2 does not equal 10. So x equals 8 is not a solution. We have no alternatives to test on this. So guess what? There is no solution. When your only solution does not work out, then there is no solution. And let's look at the reasoning to kind of noodle our way through this. How can you determine that the equation square root of x equals -5 does not have a solution without going through all the steps of solving the equation? And we're going to look at square roots as far as what's not allowed. What do you think, Nathan?
You can't really can't get negative square.
Right. When you square root something, you can't get a negative outcome. So we know that the square root of x equals -5 is going to have no solution. There is never an area where square root of x equals -5.